Hello everyone, this is Adhish. I'm a grade 10 student from Mumbai. So today's problem is can reach. This is the second problem in today's contest, and that's why it also has a difficulty level of cakewalk. And you only need to know how to check if one number is divisible by another number in order to understand my solution. You don't need to know invariance, but this is a powerful idea which we will learn through this problem. So this is not exactly a prerequisite, but this is something which you will come to understand through this problem. So this problem can actually be thought to be a bit easier than the first problem, and I'll be explaining why exactly. So in this problem, we are basically given a 2D plane instead of a 1D plane as in the first problem, and we have started at the origin, which is 0, 0, and we need to go to the coordinates x, y, which is the location of the hostel. Now, to go from 0, 0 to x, y, we can either increase or decrease the coordinate by k or minus k. So basically, let's say we were at 0, 0, then we can go to either of four positions k, 0, minus k, 0, 0, k or 0, minus k. And we can repeatedly do this until we reach the coordinates x, y. And we need to print whether or not it's possible. So notice that in the first problem we had a very similar thing. However, we needed to print the minimum number of bytes also. So in this case, we don't need to print the minimum number of steps. We only need to print whether or not it's possible to reach the coordinates. So let's consider the examples. So we are given four test cases, which is the first line in the input. And each test case contains three integers, x, y, k. Remember that x, y is the coordinates of the hotel which we want to reach, and k is the value which we can increase or decrease the current coordinate by. And let's consider these four examples for one sample test case. So the four examples are, we want to reach 1, 2 when k is 1. So in this case, note that we can start from 0, 0 and increase the value of the x coordinate by 1 because k is 1, and that will be 1, 0. Then we can increase the y coordinate by 1 to become 2, 1, 1, 0. So then we can increase the y coordinate by 1 to reach 1, 1, and then we can increase the y coordinate by 1 again to reach 1, 2. In this way, we start from 0, 0 and reach 1, 2. Then similarly, we can try and find a way to reach 3, minus 5 from 0, 0. Now, over here, we make our first key observation, which is each time we are either increasing or decreasing the coordinate by k, right? Because that's what the problem is saying. So each time, in this case, our coordinate will always be a multiple of 2, right? So for example, let's say we were at 0, 0 and we tried to increase it by 2 to become 2, 0. Now we are trying to make the x value equal to 3. However, we can only increase it by 2. So when we increase it by 2, we skip 3 and make it 4. And 4 is a multiple of 2. So each time we are only jumping to the multiples of 2. And that's why we can't ever reach 3 because 3 is not a multiple of 2. And that's why we print no. So that's why the first example would be yes, and the second example would be no. Now, for the third example, let's again start from 0, 0, and let's try to go to minus 9, minus 6. So again, we first will try to make the x value equal to minus 9, and secondly, we'll try to make the y value equal to minus 6. So this is our second observation, which is we need to first make the x value equal to minus 9, and then we need to make the y value equal to minus 6. So if both happen, if both conditions are met, then we'll print yes. Otherwise, if we are not able to make the x value equal to minus 9 or the y value equal to minus 6, then we'll print no. So in this case, we can see that we can decrease by 3. We can decrease the x value by 3 to get to minus 3, 0. Then again, we keep going to the multiples of 3 progressively. So that's why we go to minus 6, 0. and then we go to minus 9 comma 0. And then we try to make this y value equal to minus 6. So to do that, we again repeat the same process twice because we are trying to go to minus 6 and we are operating on the y values. So we decrease the y value by minus 3 and then we decrease it by minus 3 again to get minus 9 comma minus 6. And that's why we have successfully reached the hostel, which is at minus 9 comma minus 6, and we'll print yes. Now, the key observation still holds that the x coordinate, in this case minus 18, should be a multiple of k, or in this case 5. Now, the x coordinate is not a multiple of 5. That's why we can't reach this particular x coordinate. However, let's consider another example. So, like that's why the answer would be no for this case. But let's consider another example where we have minus 18, or let's say we have minus 15, comma 12. In this case, we can successfully reach the x coordinate because we are always decreasing the x coordinate and we are always ensuring that the x coordinate is a multiple of 5, right? That's the first observation which we made, and that's why we can basically make the x coordinate equal to minus 15. However, the same observation holds true for the y coordinate because they are interchangeable, right? If you can make the x coordinate minus 15, then you can also make the y coordinate minus 15. So that's why even the y coordinate should be a multiple of 5. However, if you try to simulate this process, you'll realize that 12 is not a multiple of 5. That's why when you try to increase the y coordinate, so if you try to increase the y coordinate, you will reach minus 15 comma 10. However, you won't reach the y coordinate to be minus 15 comma 12 because 12 is not a multiple of 5 and 12 lies between two multiples of 5. So that's why you will never be able to reach 12, and that's the general idea. So now, in order to prove, or in order to basically get an understanding of what this kind of technique is, or how you'll be able to generally solve this kind of problem, is the powerful idea of an invariant. So an invariant is basically something which does not change or which remains constant. So this concept of an invariant is that the position x comma y will be reachable from 0 comma 0 only when x is divisible by k and y is divisible by k. This is the general observation which we made because we noticed that each time we are either decreasing or increasing by k, and that's why the coordinate will always remain a multiple of k. And this is our invariant property. The invariant is that x and y should be both divisible by k, and that's the idea of an invariant, and that's basically what this problem was testing you. So in future problems, you can always think along the lines of the quantity which does not change. So in this case, the quantity which does not change is that x and y should both be multiples of k. It starts from 0 comma 0 because 0 is a multiple of every number, and it continues every time we increase or decrease by k. So to summarize the logic, we just need to take in the values of x and y from the standard input, and we need to print yes if x percentage k is 0 and y percentage k is 0. Otherwise, we'll print no. And the code for this is as simple as it sounds. For the C++ code, we just need to take in the value of x, y, and k. If x is divisible by k and y is divisible by k, we print yes, otherwise we print no. And for the Python code, we do almost exactly the same thing. In the try block, we'll take in the value of t. While t is greater than 0, we'll take in x, y, and k. If x is divisible by k and y is divisible by k, we print yes. Otherwise, we print no. And notice that you can print in either uppercase or lowercase. That's why it doesn't matter whether you put in uppercase or lowercase. And we'll decrease t by 1 so that we can take in the next test case. And in the except block, we'll put pass because that's how the input output works in Python. So that's all for this problem. I hope you like this problem and my solution. If you had any doubts, do leave them in the comments down below.